The graph of y is equal to absolute value of x is reflected across the x-axis and then scaled vertically by a factor of 7. What is the equation of the new graph? So pause the video and see if you can figure that out. All right, let's work through it together now. Now you might not need to draw it visually, but I will just so that we can all together visualize what is going on. So let's say that's my x-axis, and that is my y-axis. Y equals the absolute value of x. So for non-negative values of x, y is going to be equal to x. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So it's going to look like this. It's just going to have a slope of 1. And then for negative values, when you take the absolute value, you're going to take the opposite. You're going to get the positive. So it's going to look like this. Let me see if I can draw that a little bit cleaner. This is a hand-drawn sketch, so bear with me. But hopefully this is familiar. You've seen the graph of y is equal to absolute value of x before. Now let's think about the different transformations. So first they say, is reflected across the x-axis. So for example, if I have some x value right over here, before I would take the absolute value of x and I would end up there. But now we want to reflect across the x-axis. So we want to essentially get the negative of that value associated with that corresponding x. And so, for example, this x, before we would get the absolute value of x, but now we want to flip across the x-axis and we want to get the negative of it. So in general, what we are doing is we are getting the negative of the absolute value of x. In general, if you're flipping over the x-axis, you're getting the negative. You're scaling the expression or the function by a negative. So this is going to be y is equal to the negative of the absolute value of x. Once again, whatever absolute value of x was giving you before for a given x, we now want to get the negative of it. We now want to get the negative of it. So that's what reflecting across the x-axis does for us. But then they say scaled vertically by a factor of 7. And the way I view that is if you're scaling it vertically by a factor of 7, whatever y value you got for a given x, you now want to get 7 times the y value. 7 times the y value for a given x. And so if you think about that algebraically, well, if I want 7 times the y value, I'd have to multiply this thing by 7. So I would get y is equal to negative 7 times the absolute value of x. And that's essentially what they're asking. What is the equation of the new graph? And so that's what it would be. The negative flips us over the x-axis, and then the 7 scales vertically by a factor of 7. But just to understand what this would look like, well, you multiply 0 times 7. It doesn't change anything. But whatever x this is, this was equal to negative x, but now we're going to get to negative 7x. So let's see, 2, 3, 4, 5, 6, 7. So put it something around that. So our graph is now going to look like this. It's going to be stretched along the vertical axis. If we were scaling vertically by something that had an absolute value less than 1, then it would make the graph less tall. It would make it look wider. Let me make it at least look a little bit more symmetric. So it's going to look something like that. But the key issue, and the reason why I'm drawing is so you can see that it looks like it's being scaled vertically. It's being stretched in the vertical direction by a factor of 7. And the way we do that algebraically is we multiply by 7. And the negative here is what flipped us over the x-axis.